Here are a top view and a section view through a block with holes of various kinds of shapes, so you can see all together what they look like compared to each other. Notice the first one goes all the way through, so it does not have a depth. The second one only goes part of the way down, so it gives a diameter and a depth. The next to the end is the countersink, which we talked about last time. There's the countersink with the 82-degree angle. And now we'll talk about the counterbore, which, as you can see, has a bigger hole that goes straight up and down. And this kind of hole accommodates things with bolt heads or screw heads that go straight up and down, like the socket head screw, for example. Here's a side view and here's a top view of a socket head. So you can see how that kind of bolt or screw would sit down into this counterbore and would not stick up above the surface, which is our goal. The counterbore bit that does the cutting cuts a bigger hole here, whatever diameter you tell them. And notice how, let me back up. This U-shaped thing here is the symbol for a counterbore. Notice how the symbol is actually the shape of that bigger hole there. Here's ASME showing us the call out for a counterbore. So when you call it out, you must have the diameter of the smaller hole, there it is. You must have the counterbore symbol and the diameter of the counterbore, which is bigger than the hole, and the depth of the counterbore. What they are showing us in the second example is that if you prefer, you could dimension the depth of the counterbore instead of using a depth symbol. Either one is acceptable. Here is ASME showing us those two different versions. And like with the countersink, you can combine leader line callouts and dimensions as we saw here. You can combine them. But you've got diameter of the smaller hole, diameter of the bigger hole. Oh, they're missing their counterbore symbol. Oops. Here we go. And according to ASME, you can have like a stair-steppy counterbore. You might have, I don't know what these are, some kind of big bolt head and some other kind of spacer thing that goes on top. So you can actually have multiple lines of counterbore call out. Now you can also use the counterbore symbol for what's called a spot face. We won't draw that in this class. But a spot face is just a cleanup of a bumpy surface. You might find this if you were doing a casting, for example. You know how a metal casting is kind of bumpy. And let's say you just want them to flatten off the bumpy surface enough so that a washer or a bolt head could sit flat on there. You use the counterbore symbol with an SF for spot face inside. Here again is the source document. This is what ASME has to say about counterbores with their examples. I just threw this in because it's interesting. This is from a later section in the ASME Y14.5 standard, where they have gone on to talk about geometric dimensioning and tolerancing, and they are showing those kinds of tolerances applied to some counterbored holes. Finally, this is the assignment we'll be drawing. This is some kind of, I don't know, bolting flange with a hub sticking out. And it's got 4 holes around a bolt circle. They are counterbored. Then it has a smaller hole through the flange, might be for a set screw or something. Then it has a hub that sticks out. That hub is 1 3/4 diameter and it sticks out. And there's a hole all the way through the hub and the flange. So this stuff at the top is what our book shows us. I'm asking you to draw it like the example on the bottom, which you'll also see in the assignment file. Draw it like I've shown on the bottom with that little set screw hole on the 0° center line, so that when you draw the side view, you can represent that little set screw hole right in the middle here. You will draw the counterbore holes following that convention we learned a couple of lectures back. Instead of projecting construction lines over from the front view, which would give a confusing side view, you don't do that. You draw the side view as if there were only 2 counterbored holes 180 degrees apart. And that's what you show in your side view, so that your machinist can clearly see, oh, those holes are equally spaced away from the center of the part, and they're this distance away.